Welcome back. In this lecture, we will elaborate on certain new hybrid vehicle architectures. In a previous lecture, we had introduced parallel hybrid architecture. In this introductory lecture, I won't present this again. We will present newer architectures. Let's begin with a series hybrid architecture. So in this, CVT refers to continuously variable transmission. What it means is that the power from the motor to the differential can be varied in a continuous manner. So depending upon the needs of the vehicle, the power requirement will be different. Therefore, different amount of power can be transmitted from the motor to the differential. So you begin with the fuel. The energy transformation is chemical. When a fuel is combusted, uh, that provides the energy for running the engine. So this part is chemical. From the engine to the generator, the approach to energy conversion is mechanical. You rotate something, therefore you generate electricity. So this part is a mechanical approach to energy conversion. Then what is seen are these double arrows, right? Double-edged arrows. So that means by running the generator, you are charging the battery. And then the generator can also be utilized for running auxiliary loads. That is, like, for example, you are having an air conditioning system in the vehicle or lights of the vehicle. All these things can be supplied from, from the power that is produced from the generator. And most importantly, the generator can also run the motor that is used for driving the vehicle. So there is also this pathway. So the motor can not only be run from the generator, the battery can also run this motor. So either directly the generator can run the motor or the battery can run the motor. So why is this called a series architecture? So the engine may operate at a particular power. Okay, so all the power from the engine goes towards the generator. So let us try to contrast this with the parallel architecture so that the differences are clear. So in the parallel architecture, the power to the vehicle can be supplied either through this pathway, that is fuel to the engine, to the transmission, to the vehicle, or if there is, let's say, a lot of power that is required temporarily, that extra power could be supplied via the battery to the voltage converter, which runs a motor. Okay, so this is a pathway that is in parallel to this pathway. In contrast, this is in series to this. The engine cannot directly supply power to the motor. It always has to operate through the generator. So that is the big difference. But there is also advantage, okay, in the sense that you may be able to operate this transformation at a particular rate, wherein the engine operates at the most efficiency. This can be made, the engine can operate in a narrow region where the fuel consumption is minimal and its efficiency is maximum. So that is the advantage of this architecture. But as I've stated many a times, engineering is about trade-off. The trade-off here is there are additional conversion steps, right? So the engine can never transfer power directly to the motor. So there is a conversion from here to here and then from here to here. So this additional conversion processes might involve some losses. That is the disadvantage. So this particular kind of architecture is called series hybrid architecture. This is parallel hybrid architecture. All these things are hybrid vehicles, right? In the sense that besides an internal combustion engine, there is also battery power. Therefore, it is a hybrid architecture, and it is not an all electric architecture in the sense that you do not have only batteries, you also have a engine, okay, internal combustion engine. Therefore, it's a hybrid architecture. In contrast to the parallel architecture and the series architecture is the start-stop hybrid architecture. So let's see the advantage of this particular architecture. Supposing the vehicle is not moving, okay, so if the vehicle is at rest, even then you may want to have some power. For example, you may want to have the air conditioning on, or you may want to have the radio in the vehicle on, or you may want to have some lights inside the car switched on. So the power for doing all these things, accessories and so on, is provided by the battery. RESS refers to rechargeable energy storage system, can be just a battery. So the battery can provide power to running these accessories even when the engine is not operational. So in this start-stop hybrid architecture, fuel consumption goes towards running the engine, goes towards transmission and running the vehicle. So that is the main role of the engine. Okay, the dominant power towards, or the power towards running the vehicle is provided by the engine. But when the vehicle is not running, the engine can be switched off completely because this low level of power requirement just to run the radio or air conditioning is not provided by running the engine, because to provide low levels of power, operating the engine might not be very efficient. For providing low amounts of power, a battery can be operational. In addition, when you are, let's say, in starting the vehicle, you may need some sudden burst of energy that can be done via this kind of a system. That is, a rechargeable energy storage system can provide an energy during the starting the vehicle, in addition to the power that is obtained from the fuel. So this architecture is most relevant for operating the vehicle in this manner. That is, even when the vehicle is switched off, this engine can be switched off and there is an additional provision for running the accessories. This is called the start and stop hybrid architecture because the characteristic of this architecture when the vehicle is stopped is very different from the previous architecture. And during the starting of the vehicle, this architecture is also different from the previous architecture. So all these things have to be seen from the previous lecture. That is, this engine operates at least fuel consumption and maximum efficiency in a narrow range of operational condition, narrow speeds and narrow torque requirement, not torque output. All right, because of all these reasons, hybrid architecture is preferred. We will emphasize these issues in the context of start-stop hybrid architecture, which will be the topic of the next lecture. Thank you.